In the last section, we talked about exponential functions. Here, we're going to talk about logarithmic functions. And you might say, Jason, what the heck does an exponential function and a logarithmic function have to do with each other? Why are they right next to each other? We'll answer that in this video. So let's start with a familiar example from last section. We fold a piece of paper X number of times. Its thickness, F in miles, can be modeled by this function approximately. How many times do we need to fold it until it reaches the moon? So we answered that last time by graphing it on Desmos. Today, we're going to answer this question with logarithms. You might say, I don't see any logarithms here. Well, stay tuned to figure out how we're going to solve this equation. We can't solve this equation for X yet, right? We need the distance, the thickness to be 238,900. So that needs to be our F. You need this to equal 0.0000006 times 2 to the X. We need to solve this equation for X, and we have no way of doing this. Like, we can get part of the way, right? We can divide both sides by that 0.0000006 and divide this by 0.0000006. But then on the right-hand side, when we cancel, we're going to get 2 to the X just equals whatever giant number that is, 238,900 divided by, woo, that's a big number, 3.982 times 10 to the 12th. But we have no way of getting X by itself from here. So let's recap how we solved equations in the past. If we had like something like multiplication, if X is being multiplied 5 times X equals a number, we can solve for X by dividing. We undo the multiplication with division. If X was getting squared, we could solve by undoing the squared with square rooting. If X was getting added to 5, we could undo the adding by subtracting both sides by 5. But here, X is in the exponent. X is the thing being exponentiated. How do we undo an exponential function? We don't have a way yet. So that's what a logarithm is. The logarithm undoes the exponential function. If you remember nothing else from this section, remember this. A logarithm undoes an exponential function. The technical term is inverse, but it undoes it. So logarithms can have different bases, just like exponentials have different bases, right? So we have, this is an exponential function. This is an exponential function. This is an exponential function. They just have different bases. Similarly, logarithms have different bases as well. So if the base of the logarithm is some number b, then we write it a logarithm like this. And it undoes the exponential with the same base. The base of the logarithm is the base of the exponential function. So get this. Logarithms, confusing, weird, hard. Exponential functions, much nicer most of the times. So the following two statements are identical. These two equations mean exactly the same thing. There is no difference between these two equations. All right? If this were like one of those spot the differences thing, you wouldn't be able to spot any differences. They're the same. B to some a exponent equaling c is the exact same thing as the log base b of c equaling that a. The base of the exponent is the base of the logarithm. The input of the exponential function is the output of the logarithm. They undo each other, they're backwards. And the output of the exponential function is the input of the logarithm. So it kind of switches everything, but the bases are the same. So one property is since they undo each other, then like if we divide and multiply by the same number, it should cancel out. We add and subtract the same number, it should cancel out. Well, similarly, if we log and exponentiate the same number, they should cancel out and we should just be left with that number. And the reverse order is also true. If we exponentiate a number and then log by that same number, those should cancel out and we're just left with that x. So it looks weird, but let's get some practice with this. Here's an equation in exponential form. A lot of times we'll call this exponential form over here and log form over here. And we're going to say, convert this to a logarithmic equation or log form or logarithmic equation, either the same. So we know that these two things are identical. We just have to figure out what things are. So we know that in log form, it's going to look like log base something of something equals something, right? Just looking at this. So we know the base of the exponential is the base of the logarithm. The base of the exponential is going to be the base of that logarithm. The input of the exponential should be the output of the logarithm. And you can see in our formula up here, right? The exponent, what's inside of the exponential function, is outside the output of the logarithm. So those are the same two numbers. And then similarly, the output of the exponential function, that's c, is going to be the input of the logarithm, that c up there. So these two things, these two statements, exactly the same. They mean exactly the same thing. So the exponential form, 2 cubed equals 8. We look at that and say, yeah, 2 cubed equals 8. Sure, that's true. I understand that. This right-hand form, log base 2 of 8 equals 3, that's less comfortable. So in this whole section, we're going to switch things back and forth. Another way that you could do problem A is you could take log base 2 of both sides. Just like we can add 5 to both sides of an equation. We can divide both sides of an equation by any number. Well, we can log both sides of an equation too. So that's one way of doing it. Another way of doing this is logging both sides of the equation. If we log the left-hand side of the equation and log the right-hand side of the equation, what do we get? Well, if we log the left-hand side of the equation, we get log base 2 of 2 cubed. Log the right-hand side, we get log base 2 of 8. How does that simplify? Well, we have some properties of logarithms. The log base b of b to the x, they cancel out. We're just left with that exponent. Log base 2 of 2 cubed, they cancel each other out. We're just left with that exponent. So I say there's two ways of solving the same problem because look, either way we get to this answer, it's the same answer. Just, the equation's written in the other direction, but it's the same equation. So October, please stop climbing my curtains. So try to do B on your own. Either way, the way we did it on the left or the way we did it on the right. Try to pause the video and see if you can do B. All right, so we need a log form. So it's going to be log of something equals something else. The base of the log is the base of the exponential. You could write log base 10. But remember, wait, I was going to say remember something. I was going to tell you to remember something in a future video. It's in my past. It's in your future. So we're going to write log base 10. Okay. The input of the exponential should be the output. They undo each other. They're backwards. Input of one is output of the other. And then similarly, output of one is the input of the other. So this is what it looks like in log form. Or again, you could get to the same place by taking log base 10 of both sides. Up here we did log base 2 because the base of the exponential function was 2. Here we're going to take log base 10 of both sides. That's another way of getting here. And we get log base 10 of the left-hand side equals log base 10 of the right-hand side. And just like before, the left-hand side, these undo each other. The logarithm undoes the exponential function. Undoes. And we're just left with that exponent, -4. And you can see that we have the same answer. Like so. 2 ways getting to the same answer. Now, can you go backwards? If we start with log form, can we get to exponential form? Okay, well, it should be 6, because that's the base of the logarithm. 6 raised to some exponent equals something else. Those aren't zeros. Those are supposed to be circles. The input of the logarithm is the output of the exponential function. The output of the logarithm is the input of the exponential function, and hopefully this is a true statement. Remember that an exponent of 1/2? That's what a square root is. Exponent of 1/2, square root, same things. Or you could do this another way. You could exponentiate both sides. Instead of logging both sides, let's exponentiate both sides. If we do 6 raised to the power of log base of the left-hand side, that should equal 6 raised to the power of the right-hand side. And then we have that property, right? If we exponentiate a logarithm and they have the same base, that cancels and we're just left with what's inside of the logarithm. So exponentiating a logarithm, they have the same base, that cancels, and we're just left with the square root of 6. So again, 2 ways of doing these problems to get the same answer. Try the same thing on letter D. Pause the video, see what you get. Base of the logarithm, base of the exponential function. Input of the logarithm is the output of the exponential. And output of the logarithm is the input of the exponential function. Or you could do this other method over here. Either way, this is a true statement, and this is exactly the same true statement. 3 squared is 9, that's true. All right, make sure we always get true statements. And why this is so useful is we're going to use it later on to solve logarithmic equations. How do we solve this for x? Oh, that's kind of hard. Let's put it in exponential form. Exponential form or as an exponential equation. And watch what happens. So the base of the logarithm is the base of the exponential function. The input of the logarithm is the output of the exponential function. And the output of the logarithm is the input of the exponential function. This is the exact same statement. This, same exact equation. Might look a little different, but it's the same thing. So what's x? Now it's a much easier question to answer. What is x? It must be 16. It's 4 squared. That's our solution. You've solved your first logarithmic equation. More to come. More where that came from. Things to look forward to. And again, for b, we have kind of an idea. It should be a number between 3 and 4. Because 2 cubed would be 8. 2 to the 4th is 16. So maybe some number closer to 3. But we can't find it exactly right now. So what we're going to do is we're going to convert this to a logarithmic equation. The base of the logarithm should be the base of the exponential function. It should be 2. Input of the exponential function is going to be the output of the logarithm. And output of the exponential function will be the input of the logarithm. We'll have log base 2 of 10 equals x. I never really specified how you say that, so let me say it right here. We say log base 2 of 10. That's how this is said. Okay, verbally. And now you might say, but Jason, this doesn't help me solve. Well, we'll get there. Okay, we'll get there. But what we're really going to do eventually, you don't need to know how to do this yet. Your calculator can help us do that. And it can help us do it in a couple of different ways. Log base 2 of 10. You don't have to worry about where this is coming from yet. But your calculator can evaluate this. It's about 3.3219. I said it should be a number between 3 and 4. Looks like I wasn't lying today. All right. So again, this is what you should be able to do now. And this is what you'll be able to do by the end of this section. Let me know if you have any questions. And have a good rest of your day. Bye-bye. It's October, if you're curious what I'm looking at. He's feisty tonight.